Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are continuing our journey with gradient, which is another word for slope. So I will be saying gradient, I will be saying slope. It's the same thing. All of these say slope. Here we got rise over run, which is the definition of gradient or slope. It is a measure of change. All right, so we'll check back in with the Great Cranberries and the epic song Dreams in just a second. So today in class, we had a little exercise where we graphed some parallel lines, and we discovered that parallel lines have the same slope. So if this line is parallel to this line, and I know that this line P here has a slope of -3, then I know that any line parallel to it has a slope of -3. Here, what was the slope? 2/3. So if this line is parallel to it, it also has a slope of 2/3. Then we move to perpendicular lines, and we had a little bit of a mishap here, so I just want to calculate it just to make sure. On graph C here, we did great. The slope of line R is -4, and the slope of line S, I don't think it's labeled, is 1/4. Okay, and to find the slope of line A here, so line A, I'm going to say M equals y2 minus y1 over x2 minus x1, and I get, let's see, 5 minus a -4 compared to 1 minus a -3. 1 minus a -3. So that becomes 5 plus 4, or 9, and 1 plus 3 is 4. And if we look at the relationship here, this was a -4, and if we think about it as -4 over 1, the slope of the line perpendicular to it is 1 over 4. So what changed? Well, it became the reciprocal. The reciprocal of, if we forget about the negative, the reciprocal of 4 over 1 is 1 over 4, and then the sign changed. So let's see if the same thing happens here. Okay, so for line B, I'm going to do the same thing, and the gradient would be equal to, here's line B, and so this is, let's just get the points correct, that's where it was messed up. 4, 0, and -5, 4. Okay, so it would be 4 minus 0 for the change in y over -5 minus 4, the change in x. So that's equal to 4 over -9, which makes the whole thing negative. Okay, so if you look, we had 9 over 4, and the slope of the line perpendicular to it is the reciprocal. We switch the 4 and the 9, and we change the sign. Okay, and that was the purpose of that exercise. So we could see that parallel lines, if two lines are parallel, then they have equal gradient, they have the same slope, and the other way around, if two lines have equal gradient, then they're parallel. And then here it says if lines are perpendicular, and remember, perpendicular means the lines form a 90-degree angle or a right angle, then their gradients are negative reciprocal. Okay, so line 1 has gradient of 3 over 1, so line 2, since it's perpendicular, I flip the 1 and the 3, and I get 1/3, and then I change the sign. Okay, so we say they're negative reciprocals of one another. So let's just do a quick couple of examples. So here's a few examples we're going to do. Okay, so if a line has gradient 2/3, find the gradient. Remember, gradient is the same thing as slope. Okay, all lines parallel to the given line. So if a line has gradient 2/3, all lines parallel to the given line also have a slope of 2/3. Okay, so that would look something like this. Okay, two lines. That's about a slope of 2/3, depending on the scale, of course. Okay, and then B, all lines perpendicular to the given line. Well, I just have to take the negative reciprocal of 2/3. So the reciprocal is 3/2. I like to say opposite reciprocal, opposite, because right now it's positive, so opposite of positive is negative, okay? And that would look something like this, okay? So this would be the line with the slope of 2/3. This is something like a line with slope of negative 3/2, and they would form a right angle. That's what perpendicular means, okay? Two more examples and I'll shut up. Find A, given that the line joining A to B is parallel to a line with gradient 2. Okay, well, we're going to start with our formula for gradient, which is y2 minus y1 over x2 minus x1. Okay, well, if the lines are parallel, then their slopes are the same. So we need the line going through point AB to have a slope or gradient of -2. So since m represents slope or gradient, I'm replacing m with -2, okay? And then I'm going to use the slope formula here. So that would be y2 minus y1, so -1 minus 3, all over x2, which is a, minus 2. And now I just have to solve this for a. And so what we're going to do now is we're going to do this using cross multiplication after we simplify up on top, because we do have a -1 minus 3 up there, which we know becomes -1 minus 3 is a -4. So I'll do the right side first, -4. -1 minus 3 is -4. Can't do anything with the a minus 2. Okay, and instead of -2, I'm going to think of it as -2 over 1. Now, to solve for a, I'm going to cross multiply this times this, this times this, and they have to be equal to one another if we have an equal signs, obviously. So let me just move up here, gives ourselves a little bit of room. -2 multiplied by a minus 2. The parentheses are really, really important when you have more than one term, because we're going to have to distribute this, and that must be equal to 1 multiplied by -4. So -2 times a is -2a, and -2 times -2 is +4, and that equals to 1 times -4, which is -4. And if I subtract 4 from both sides of the equation here, I end up with -2a is equal to -8. Divide both sides by -2. The -2's go away. Kapow! I'm left with a, and that's equal to 4. So -8 divided by -2, a equals 4. So that means when a equals 4, the line through AB is parallel to any line with gradient of -2. It also means the line AB must have a gradient of -2. Next example, last example, find T, given that the line joining D and C, which includes the point T right there, is perpendicular, not parallel, but perpendicular to a line with gradient of 2. So remember, perpendicular, and that is the symbol for perpendicular. Then we don't have to write this word all the time. Perpendicular lines have gradients with opposite reciprocals. Opposite reciprocals. Okay? So the gradient in question right now is 2. So I'm going to think of that as 2 over 1. But a line perpendicular to it is going to have a slope of the opposite reciprocal. Let's do the reciprocal first, meaning you just switch the numerator and the denominator and take care of the opposite. Okay, it's positive, so now it's going to be negative. If it was negative, then it would become positive. Then I'm going to go back to my slope formula to solve for t, because I know that the slope is equal to y2 minus y1 over x2 minus x1. Okay, there's the 2. And I need my gradient slash slope. Again, gradient and slope mean the same thing. Must be equal to negative 1/2 if it's going to be perpendicular to a line with gradient of 2. So I'm going to let m be negative 1/2. And then I'm just going to use my formula. y2 minus y1. So y2 happens to be t. So that's going to be t minus a negative 3 over the difference in the x-coordinates, which is 1 minus a negative 1. And so we simplified this a bit. Negative 1/2 is equal to t minus a negative 3 is t plus 3. And 1 minus a negative 1 is 1 plus 1, or 2. All right, so now I'm going to cross multiply again. So I will take 2 times the quantity, t plus 3. And again, do not forget the parentheses here, because that reminds you to distribute the 2 through the parentheses, is equal to negative 1 multiplied by 2. And 2 times t is 2t. And 2 times 3 is 6. That equals negative 2. So I'm going to subtract 6. And I get 2t is equal to negative 8. And then I divide both sides by 2 to solve for t. And life is good. That's the way it should be. We get t equal to negative 4. Meaning, if I have the point, if I draw a line through DC, and where C has a point 1, negative 4, it will be perpendicular to a line with a gradient of 2. That is it. That is all that I have. I hope you enjoyed it. I certainly did. We will go out with the cranberries as we came in with them. And with that, I am out.